problem 7 is another statics problem, although we're talking about a situation that normally you end up with some dynamics as you're going down the road. And it points out the fact you need to be careful about how you load a trailer. I actually came along once, and the chair of our art department had, he was picking up some heavy artwork, and they had put the load too far back, and they hit a bump, and the fact that the load was too far back meant that the force the hitch was having to provide needed to be downward instead of upward, and the trailer just popped off the hitch. So you need to be careful about how you balance a load on a trailer. And this one in particular, we're going to have an upward force on the hinge, on the hitch. We're going to have an upward force at the axle, from the axle. We've got a downward force due to the mass of the trailer. And we have another downward force that's somewhere. I'm going to call this distance x. We have another downward force that's somewhere here, and we're trying to figure out what that needs to be, and that's going to be a distance y, and I'm putting these in reference to the axle. All right, so the center of mass of the trailer is in front of the axle. Fractional weight supported by hitch can be no more than 109 kilos. So that's a few hundred pounds, right? 109 kilos. What is the furthest in front of the axle you can position center of mass? The engine. And so what we're after is we want this, right, the fraction of the weight up here, to be equal to the force of 109 kilos. So this force, F of the hitch, needs to be 109 kilos times 9.8 meters per second squared. That's the fraction of the weight that we want this to have to support. All right, we know X, we know Y, we know hitch to axle, we know that distance. That's 312 centimeters. I'll call that Z. There we go. So we got the engine, we've got the distances, we've got the trailer body, and so the thing we don't know is what can that Y be and meet this condition up front that the amount of force that we're asking the hitch to provide is no more than its limit. And you're going to want to stay a little ways away from that because you're going to hit bumps and bumps. If you ever pull a trailer, you want to be careful with this. Okay, so let's look at the torque. And let's look at the torque about the axle back here. And so if we look at positive torques, well, the trailer mass is going to give us a positive torque. The engine being in front of the axle is going to give us a positive torque. And then the hitch has to give us a negative torque. And so we've got mass of the engine, G, times the distance. It is, that's Y, from the axle. We don't know that distance yet. Plus mass of the trailer times G times the distance it is, minus the force from the hitch times the distance to the hitch. All of that has to be 0. So we put together our torque equation. We know the mass, we know this mass, we know that distance, we know this force because we're given enough information to figure out what it needs to be. We know that distance. The only thing we don't know in this equation is Y, which is what we're looking for. How far in front of the axle, how far in front of that point of rotation can we put this center of this engine, the center of mass of this engine, and not put too much force on the hitch. And that's it for problem 7.